All right, here's our last example for this section. So Michael Sullivan, son of the author of our textbook, decided to enroll in a reading course that allegedly increases reading speed and comprehension. Prior to enrolling in the class, Michael read 198 words per minute. The following data represent the words per minute read for 10 different passages read after that course. Was the class effective? Use the alpha equals 0.1 significance level. And we have a table of data. All right, so they gave us quite a bit. Notice that we're interested in reading speed. And it does take a little bit for us to maybe, get into that mode of like, okay, what is exactly are we talking about here? So let's see. The main question is, was the class effective? So what does it mean if the class is effective? Notice this, it increases reading speed. So is there evidence that the reading speed is higher now? So notice prior to enrolling in the class, Michael was reading at 198 words per minute. So that right there is the claim, right? We're going to assume the no change hypothesis. We're going to go ahead and say, okay, obviously here so let me maybe just list out all of the items that we need. So what is the parameter? And obviously we're looking at reading speed, but not for everybody. We're just interested in Michael's reading speed. So here's going to be mu, which is the true reading speed. I guess mean reading speed. Of Michael Sullivan. All right, now let's take a look at our hypothesis. So the hypothesis here is going to be that the reading speed is the same as it was before, so 198. We're interested in whether the class was effective. Remember, if the class is effective, it means that reading speed has gone up, so increased reading speed. So that means mu is higher now. Okay, so it takes a little careful reading here to really determine the appropriate hypothesis, but then everything else is pretty simple. The requirements always SRS independence. But more importantly, we're going to ask if we have the shape requirement satisfied. So for our shape requirement, we need a sample size greater than 30, or we need the population to be normal. So obviously we don't have a big enough sample size. We only have 10 different passages. So this would be X1, X2, X3, X4, X5. There's only 10 different samples of reading speeds. So now we need to go ahead and ask, well, is there evidence that the population is normal? So we've done this in the past, so I'm just going to go through it pretty quickly. We're simply going to go ahead and check QQ plot and record the R value. And we're going to check the box plot to ensure that there's no outlier. All right, so go ahead and do that with the data. After the requirements, we want to go ahead and sketch. Sketch and label. And then we're going to go and get our test statistics. So I already know that this is a mean, therefore this will be a t-distribution. The fact that this is a greater than, right, means that I'm looking for evidence on the right tail. So no divide by 2, alpha is 0.1. So I can find t sub alpha. Degrees of freedom is 9. So let's go ahead and use StatCrunch. All right, so now that I've set everything up, I'm now primed for this sample. This is essentially the setup. Step 5, the test statistic. That's the only time that you use the sample, right? So now let's go ahead, and usually this step 5 takes forever because you actually have to go out and, collect your sample. So we're going to get our t statistic and our p-value. I already have my data in StatCrunch, so this will be easier. And remember, it's a t distribution for mean, so it's a t statistic command. So we're going to go to stats, t stats, one sample. In this case, we have data. So let's see, stats, t stats, one sample with data. And I'm going to go ahead and select the appropriate column, reading speed, and type in the hypothesis, which is 198, and greater than is the alternative. And there we have it. We've got our test statistics. So let's write those down. All right, now let me actually clearly indicate how I'm determining this check, just because this is our last hypothesis test together. So 3.5 on the number line. Remember, number line, this is 0. This is 1.3. So 3 is actually pretty unusual. It's way over here. So again, what this is saying is that our test statistic t in absolute value is greater than the absolute value of t sub alpha. So in other words, our test statistic is further away from the center than t alpha. So we're in the critical region. Because of that, we're going to reject. All right, now let's do a p-value approach. So how does the p-value compare to alpha? P-value is 0.003. Obviously, very, very small, much smaller than 0.01. So p-value is less. So again, we reject the null hypothesis. So we're going to scrap this hypothesis, and we're going to say we have sufficient evidence to claim at the 0.1 level of significance that the mean reading speed has in fact increased. You could also just say that the class was effective. And there you have it. That is pretty much it. Your next step is to complete the homework for this section. Please make sure that you reach out as soon as something is unclear, whether it be the homework or on the lecture.